Part 4 for the 16.3 practice, genetic crossings and genetics. It's about statistical analysis of genetic crosses. So, we have to use for this the epibiology equation and formula sheet. This is the chi-square table. And let's start to read over question number 14. Mendel's law of inheritance predict that the F1 offspring in monohybrid crosses will express a 3-to-1 ratio of dominant to recessive phenotypes. We covered that in the first and the second video. In one of the Mendel's experiments, he crossed F1 plants that were heterozygous for the seed shape trait. This cross produced 5,474 round seeds and 1,850 wrinkle seeds in the F2 generation. This result varies slightly from the expected ratio wrinkled peas. Is the difference between the observed and expected value significant? Is this amount of difference something that is likely to be the result of a chance event, or is something else going on? Here are some hardy steps to follow. So let's use the chi-square test at this point. What would we expect, and use these to generate our null hypothesis. So our null hypothesis will be, write it down, HO, that's the null hypothesis. That means if both parents are heterozygous, we would expect (75% of offspring to be round and 25% of the offspring to be wrinkled. Number-wise, we would expect 5, 4, 93 round and 1, 8, 31 wrinkled. How did I figure it out? I added to the the seed number, and after I just took 75% of that value to figure it out. Okay, so let's do the chi-square test. So we make a table. Okay. So this will be the category. This will be the round category. And this is the wrinkled category. We will have the expected, observed, as well as the formula is observed minus expected squared divided by expected. I'm using this formula, guys. Where is that formula? Oh, here's the chi-square formula. That's what you will be able, you don't have to memorize, you have to you can use the formula sheet. And now what we observed was, it's in the text, 5, 4, 7, 4, and I expect, I did actually 5, 7, okay, and the wrinkled one, 1, 8, 5, 0. All together, if I add this all together, it gives me 7,324 seeds. 75% of that amount of seeds is going to be expected to be around if they follow the Mendelian inheritance. So the value would be 5, 4, 9, 3, and the 25% would be wrinkled, so the expected value is 0.25 times the total value, and it will be 1,831. Okay, we will figure out these values. Okay, so you will just do 5,474 minus 5,493, subtract, square them, and divide by the expected value, and you will get 0.0657. For the second is 0.197. Make sure you guys are dividing the values by the expected value. And now what we are going to do for the chi-square test is we are going to sum it up, these two values, and what we will have is 0.26. Now, this is our chi-squared value. What we are going to do is go back to the formula sheet on here and check the degree of freedom. The degree of freedom, degree of the freedom is usually the categories, cat minus 1. So we have two categories and minus 1 is 1. So for the chi-squared number is here for the for degree of freedom 1 is with the p-value 0.05. That's what we usually have. This is the 5%. Is the value is 3.84. Okay, 3.84. Now my value is way less than the threshold value. Okay, so my chi-square value is lower than the table given value. So in this case, I fail to reject H, the null hypothesis. That means the different occurrence from the exact numbers, the expected numbers, is due to the chance instead of something else. The difference in the expected and observed values are due to chance only. So I will write that in red. We never accept H null. We never accept H null. We fail to reject null hypothesis. Okay, in statistics you never accept anything. Okay, does it make sense? Good. Let's go and do number 2. actual number 15. In a certain species, a flower plant, the purple allele is dominant to the yellow allele, lowercase p. A student performed a cross between a purple flower plant and a yellow flower plant. When planted, the 146 seeds that were produced from the cross matured into 80 plants with purple flowers and 66 plants with yellow flowers. Calculate the chi-square of null hypothesis that the purple flower parents were heterozygous for flower color gene. So, the purple flower was this. And the other one was lowercase p, lowercase p. So here is how do we know that it's a lowercase? Because it was the yellow flower, and the purple got to be heterozygous. In this case, the cross will give me a 1-to-1 ratio for the colors. How do I know? Well, in my head, I did the Punnett square. So 1-to-1 ratio. Now, let's do the Punnett square, the chi-square test. This will be the categories. Either it will be purple or yellow. We have to just get the expected and observed values, and O minus E squared divided by expected values. So what we have is 80 was purple and 66 was yellow. Altogether, it was 146 seeds. The expectation is 1-to-1, so 50% will be purple and 50% yellow. So the 50% of 146 is 73, 73, both of them. And when you do the calculations, you will get 0.67 for here and 0.67 here. When we sum it up, we will get 1.3. Again, we figure out the degree of freedom, cat minus 1. Categories, we have 2, minus 1 is 1. So this is the degree of freedom. I will get into my chart, and here is the degree of freedom 1 and 0.05. The 5% value is 3.84. So that's my value 1.3 is less than 3.84. So that means I fail to reject null hypothesis. So it means that the plant, the seed color, is that the seed color? Flower color followed the Mendelian inheritance, and one of the parents was heterozygous for the flower color, while the other one was homozygous recessive for the color. So that means that it is likely that the purple parent was heterozygous for the flower color gene. Good. And the last one here is number 16. It will be a little bit interesting for that. So that's the red allele for red, dominant, and the lowercase r for white flower. Okay. When planted, 160 seeds that were produced from the cross matured into red flowers and white flowers. We have to use the chi-square value to evaluate the null hypothesis that both parents were heterozygous. Okay, so the null hypothesis equals both parents are heterozygous for flower color. Okay, this is my null hypothesis. In this case, the distribution, if both of the parents are heterozygous, what would you expect for color-wise? 75% would be red and 25, sorry, would be white color. Okay, it's a little bit too much. Okay, so let's do the table here. This will be the categories. It will be the red and the white. And this is the expected value, observed value, and the E minus O squared divided by E. That's what I'm using, the chi-squared. Well, I used capital letters, but lowercase is fine too in here. And observed is 108. The other one is 52. And altogether 160 seeds. Now 75% of 160 is 120, and 25% of 160 is going to be 40. So when you do the calculations for here, that will give you 1.2 and 3.6. The chi-square value, I will sum it up, and the chi-square value will be 4.8. And let's check with 0.05 p-value with degree of freedom is cat minus 1 is 1. Later on it will be more. It's 3.84. So the normal, the accepted value will be 3.84. But ours chi-square value is way bigger. Come on. Way bigger than the accepted value. So in this case, we reject null hypothesis. It means that the word is like the difference between the observed and expected values is too great to attribute to chance. There must be something else going on instead of chance. So later on we will see example of the lethal dominance, which would explain how this particular trait is inherited in these flowers. But until then, well, thank you so much for your attention.